Good morning. In this mission we will practice the startup procedure for the A10-C. There's a lot to cover, so feel free to take a break by pressing the pause key at any point. It will be important for you to follow my instructions to the letter. Do not jump ahead and start mashing buttons and throwing switches. I will guide you. You can pan around the cockpit using your view control commands to locate the switch. If you find it hard to hear my instructions over the background noise, exit the mission and turn down the world and in-cockpit sound sliders to about 50% in the options menu. As described in the flight manual, a pre-flight check is normally performed prior to startup to ensure the aircraft is configured properly. However, for the purposes of this lesson, we'll begin the startup sequence with the aircraft's initial configuration set as it would be at the start of all missions. The startup procedure will consist of initiating electrical power, starting the APU, followed by the left and right engines, and finally powering up and preparing all essential avionics. Press the spacebar key when you are ready to begin. First, set the battery switch on the electrical panel on the right side console to power. This will provide power to the DC buses and the APU. Follow the highlight at the bottom right corner of the screen to locate the switch. Good. Now set the inverter switch on the same panel to standby. This will allow AC power to be supplied to numerous aircraft instruments. It will also provide power to the engine igniters. With electrical power now running, we can take a moment to test the caution and warning systems to make sure that we will receive warnings in case something goes wrong during startup. To do this, press and hold the lamp test button on the auxiliary lighting panel on the left console. Take a look around the cockpit while you hold down the button to make sure that all of the caution lights are functional and you can hear an audible warning tone. Everything looks good. Now let's test the fuel indicator to make sure it's functional and accurate. The fuel indicator is located on the right side of the front dash. When tested, the two needles should point to 3,000 pounds, and the digital totalizer readout should be around 6,000 pounds. On the oxygen regulator panel, set the supply switch to on, and check for oxygen flow to be indicated in the flow window. Press the Oxy-In Test Oxygen Indicator Test button to test the oxygen remaining indicator. Watch the Oxy-Low caution light on the caution lights panel to turn on when the indication falls below 0.5 liters. We also need to power the radios to communicate with ATC and mission assets. Set the VHF AM frequency mode dial to TR, transceiver. Now repeat the process for the VHF FM radio. Set the UHF radio function dial to main to power the UHF radio. We are now ready to begin the engine start sequence, but let's first close the canopy to minimize the noise. Right-click and hold the canopy control switch to lower the canopy, or press left control plus C on the keyboard. Starting the engines will take several minutes and require a few steps. First, we need to provide power to the boost pumps of the left and right wing tanks and left and right fuselage tanks. You will find the four switches on the fuel system control panel toward the top of the left console. Set all four switches to the up position. Before starting the engines, we need to start the auxiliary power unit, APU, which will generate bleed air used to start the main engines. As you start the APU, be ready to monitor the APU exhaust gas temperature, EGT, and RPM gauges on the engine monitoring instruments EMI panel located on the bottom right of the front dash. Go ahead and set the APU start switch to start. Now let's return to the electrical panel and set the APU generator switch to the power position. This will allow the APU generator to power the aircraft and relieve the battery drain. However, the battery needs to remain on as a backup electrical source. While on the electrical panel and in preparation of the engine start sequence, let's also set the left and right AC generators up to power. Once the engines are started, they will begin to turn the AC generators and take over from the APU to provide electrical power. Okay, time to crank up the left engine. This is a very simple process initiated simply by moving the left throttle from off to idle or pressing the right alt plus home keys. This will automatically start fuel flow, use bleed air from the APU to turn the fans, and then ignite the fuel in the combustion chamber. As the engine spools up, scan the engine monitoring instruments panel to watch the engine interstage turbine temperature, ITT, engine core speed, fan speed, and fuel flow gauges. Watch for the core fan RPM to stabilize around 60% when idling on the ground. You will also notice the left hydraulic system's pressure begin to build. This will normalize between 2,800 and 3,350 psi. Once the left engine is running normal and stable, press the spacebar key to proceed. We'll now repeat the process for the right engine. Once again, the engine is started by moving the throttle from off to idle, or in this case, pressing the right control plus home keys. As with the left engine, monitor the instrumentation as the right engine spools up. Also watch the right hydraulic system pressure to normalize. Once you have both engines running normally at idle power, you can do a flight controls check to test the responsiveness of the controls to stick and rudder input. Test the speed brakes and flaps. Press the spacebar key to proceed once everything checks out. With both engines now running and powering the left and right AC generators, we can turn off the APU generator on the electrical panel and then the APU itself on the throttle panel. Okay, now we'll power up the control display unit, CDU, and the embedded GPS INS IGE systems. This will begin the automated built-in test, BIT, and alignment processes for the navigation system, which you can monitor on the CDU display on the right console. Uncase the standby attitude indicator, SAI, on the front dash. To do this, turn the SAI cage knob to the left by rolling your mouse wheel down over the knob. Once uncaged, roll the wheel back to set the SAI aircraft indicator level on the horizon. Turn on the multifunction color displays, MFCDs, by left-clicking twice on the power switch for each display. While we are waiting for the CDU bit and IGI alignment to complete, we can continue the startup sequence. Turn on the Central Interface Control Unit, CICU, on the Armament HUD Control Panel, AHCP, on the front dash. This will provide essential user interface controls to numerous aircraft systems, including the left and right multifunction color displays, MFCDs. The MFCDs are now on. In a few moments, they will display the Data Transfer System, DTS page, which we will use to upload navigation and weapon configuration data saved on the data cartridge from the mission planner. Now, set the Integrated Flight and Fire Control Computer, IFF-CC, switch to the test position by left-clicking once. The IFF-CC provides weapon release calculations, attitude control, and HUD indication. In test mode, the system will run a series of automated bits, which you can monitor on the HUD. Press the ENT enter button on the upfront controller UFC to initiate the IFF-CC bit. This will take approximately 1 minute. While waiting for the IFF-CC to undergo the bit and the IGI system to finish aligning, let's set up our flight control systems. Set the left and right yaw and pitch SAS channels on the SAS panel on the left console to on. Now press the TO trim button to set the flight controls for takeoff trim. Let's upload data from the data cartridge. Select Load All on the left MFCD by pressing the Option Select button 10. The DTS will take about 15 seconds to transfer the data from the cartridge to the jet.
Altitude.
During this time, all the asterisks accompanying each data type on the left side of the displays will disappear. When all the asterisks reappear, the data has been transferred successfully. Once the data is loaded, set the right MFCD to display CDU data by pressing OSB 13. This way you don't have to take your head down to check CDU indication. The IFF-CC bit is now complete. As you can see on the HUD, the exit function is currently pointed to by the HUD cursor. Press the Enter key on the UFC to exit this HUD menu. The IFCC is now displaying the ground bit menu on the HUD, where you can run a number of other bits if necessary. To exit out of this menu, press the Select Rocker key on the UFC down repeatedly until the HUD cursor points to exit again. Then press Enter to exit this menu. The IFF-CC is now displaying the main menu on the HUD, where you can set up various indication and weapon release parameters. Let's take the IFF-CC out of test mode and set it to on by left-clicking the IFF-CC switch one more time. Let's set the left MFCD to the Tactical Awareness Display TAD page by pressing OSB 15. Now load up the flight plan. Right-click the steer point switch on the AAP panel to set it to flight plan. This will set the flight route to appear on the TAD display. With our flight and navigation systems ready, we can prepare some of the combat systems for the mission. Set the countermeasure signal processor mode switch on the CMSP panel to standby. For a combat sortie, you may want to review or create some countermeasures programs, but that is for another lesson. Now set the 4 system select switches to on, middle position. Next, set the Joint Tactical Radio System JTRS switch on the AHCP to on. This will provide power to the Situational Awareness Data Link saddle. With the IGI aligned, let's select CDU nav mode by pressing OSB 9 on the right MFCD. Select the EGI as the primary navigation system on the Navigation Mode Select panel. Next, arm the Enhanced Attitude Control EAC switch on the Low Altitude Safety and Targeting Enhancement LASTE panel on the left console. Note this switch is hidden under the throttle, so you may have to shift your view position to see it, but it is still clickable with the mouse. Turn on the radar altimeter. At this point, we are ready to taxi to the runway. Set the anti-skid switch to on. Now turn on the nose wheel steering by pressing the pinky button on the control stick or insert on the keyboard. Click on the yellow handle to arm the ejection seat. Taxiing out to the runway requires tower permission, so we will end our startup lesson here. Tomorrow you're going up. See you then.